Now we have Salvatore Raucci talking about completing matrix of 8 brain. Please.
Right. Okay, so first of all, let me join the other people here in thanking all the organizers for this meeting. Is it working? Okay, perfect. So I'm Salvatore from Pisa, and I'm going to tell you something about the title of my poster, Completing Matrix of 8 Brains. So let me start with some motivations. So generically, if you work in string theory and try to find some vacua for your model of string theory, you have a problem. The problem is that gravity in string theory, from the space-time point of view, is treated like general relativity. So yeah, you have the usual problems of general relativity. First problem is that the equations of motion only deal with the metric, not with the topology. So you don't have information about the topology of the manifold on which you have the metric. The other problem is the definition of the energy. You have no general definition of the energy in general relativity. So there is no vacuum in general relativity. There are many vacua, all equivalent. And the third problem is about singularities. So if you have a metric from the physical perspective, singularity means there is something there. And this concept of singularity and there is something there can be rephrased with the concept of completeness. So this is the general definition. It doesn't matter if you know it or not. Anyway, the meaning is that no geodesic should end at finite proper time if it is time-like. Anyway, so if some geodesic ends at finite time, it means there is something from the physical perspective. And this notion of completeness is equivalent to the standard completeness notion. So Cauchy sequences converge in the manifold for manifolds without boundary. If your manifold has a boundary, geodesics are not that useful. So the physical perspective of this story is that non-completeness should mean something from the physical point of view. For instance, you can take the black hole solutions, the Schwarzschild solution, and so on. So what my poster is about? Well, the story is about 8 brains. So my title could have been 8 brains, because I focus on dimension 1 object, the simplest ones. There are other arguments for other objects in other dimensions, but it is simplest to study 8 brains in this case. So I study metrics with the correct isometries. It is an 8-brain metric that can be boundaries or sources. But this is a subtle point you'll see in my poster. So my poster is about 3 dimension 1 string-inspired constructions, which are these ones. The first one is for uncharged brains, so pure Einstein dilaton with that ansatz. But it seems trivial, but there is a surprise here. The second one is charged 8 brains in massive 2A supergravity. So you can view it as a deformation of the D8 solution. And the third one is this vacuum for this non-supersymmetric string theory in 10 dimensions. So I'll just end with this slide, in which you can find one question you like and ask me later. For instance, I have a nice question here, link it to the first case. And I have some very obscure sentence here for you in the third case. Thank you.
Can you give us a teaser of what is going to be the surprise?
Yes. So if you consider the first case here, okay, it's fine. If you consider the first case here, pure Einstein dilaton, and try to, okay, and take my deformed solution, my other solution with these ansatz here, you can view it in 2 ways. First way is that it's just the solution of Einstein's equations. Second way, you can try to interpret this as a string theory solution. So coming from some stringy something source. If you try to interpret that solution as coming from the string worldsheet something, you end up studying different worldsheets. So you need a deformation of the usual string theory worldsheet. And you may want to look at my poster later.
Okay, any other questions maybe?
Yes. Yes. So here, 8 brains are boundaries. Here can be boundaries if there is no source, or are not boundaries if there is a source. So the point is that if you have a manifold which is like an open interval, you know, this is not complete because with the usual metric, because the endpoints are, you know, you can go to the endpoints, but the endpoints do not belong to the manifold. And the reasoning is like this in the first and third case. In the second case, it's more complicated because there are actual sources in string theory 8 brains that you can put in. But the most interesting case maybe is the third one, which is an open question about non-supersymmetric constructions, in which we don't know if the vacuum we have is a vacuum or is some sources or some boundaries, or whatever we want.
Okay, thank you very much. Then I think we can clap again.